This is MAE304, Turner's Cloud Archive for CNN's video library and global multi-platform versioning. Joining me on stage today is going to be Michael Cutter, SVP of Digital Media Systems at Turner, who's going to take over the bulk of the presentation, talking about what they've done in the cloud, how they've transformed, why they're transforming, and the type of technologies and things that they're thinking about from an at-scale platform delivery perspective. I'm going to talk a little bit about just framing up the presentation, giving you some ideas of the fundamentals that build the platform that Michael's going to talk about. By way of introduction, my name is Bhavik Vyas. I work on the AWS partner team, and I lead our global partnerships and alliances. If we look at media adoption in the cloud, we're very fortunate that it's very pervasive, from camera to screen. Our customers, many of which are in the audience, hopefully many of you that are thinking about it, are using the cloud to drive multiple pieces of this very complex workflow as we go from camera to screen, multiple different screens, multiple different formats. And so what we have found it advantageous to do is sort of break apart this camera to screen workflow into workloads, which can represent discrete business units, very complex macro workloads, within which are going to be all the workflows that you design and operate from a daily basis. So our customers are acquiring content, both live and file, and bringing that into the platform at scale. They're beginning to think about how production, both post-production and production, can be done in the cloud at scale. So that's where you require a lot of compute, a lot of storage, often very much based on a temporal perspective regarding projects. But moving production and post into the cloud saves potentially great efficiencies in eliminating the need to move content back on premise if you have to finish it. There are many strategies around asset management, so DAM, MAM, and archive, and really managing content throughout the entire workflow that content goes through, from high access to infrequent access to long tail. But the asset management strategies you can build can be very complex, and there are many technologies that you can take advantage of in building out that strategy. Media supply chain is where we look at, and sort of part of my presentation, and then you'll see part of Michael's, it's really the engine by which content is transformed. And I'll get that into a moment. But this supply chain concept and what we're doing and what the cloud can hopefully enable and the agility and speed that it can infuse into the business becomes a very important aspect that we think the cloud is useful for, but our customers are actually doing on a real-time basis. And then once we've got content through, we then have to monetize it. And so that monetization comes through linear playout, so broadcast and distribution. It comes through OTT platforms at scale. Those can be global platforms, national platforms, small platforms, but OTT and the delivery of video and the convergence of linear and OTT is an area where the cloud is becoming very transformational. Then there's the digital publishing aspect of digital media, so that's the social, it's the promotions, it's the user engagement. Your business could be digital publishing, in which case video now becomes a very important component, and all of this is equally applicable. And then underneath it all, we're seeing our customers drive the analytics. So how do you instrument and measure? How do you infuse artificial intelligence and machine learning into your processes to really develop next generation workloads? So if we go to the general premise, getting content in and getting content out, it's pretty simple, right? You ingest content, you store it, you process it, transform it, and then you deliver it to the consumer. If only it was actually that simple, though, right? So there's a lot of complexity around bringing content in. The complexity is about bringing live in, bringing files in at scale. The complexities around how you manage your storage as part of your asset management system, or MAM, or production asset management, or archive. What you do around production and post-production, not just the finishing of content or editing, but the dailies, the review and approval, all of the complex interactions you have with your businesses. And then the complexities of delivering. And so many of you likely represent discrete business units that are focused on linear TV or OTT, but the complexities within each one of those, as you well know, is extremely complex. And so the supply chain in between is what we see is where we see the most innovation occurring from a cloud usage perspective. Because this supply chain and what you've built on premise, all of the workloads, all of the interconnections, all of the third parties that you integrate, becomes the engine by which you deliver content to those distribution points. And what we see as we go forward with a very rapidly changing industry is that the supply chain, if it's agnostic to the output, allows great flexibility with what you do in the cloud. And so how do you get there? So one of the ways you get there is to remove reasons not to innovate and not to experiment. And so we're often always forced to think about things like, things aren't possible. we don't support that today, or we don't have the hardware to do what you're asking, or we don't have the budget, let's try this next year. But all of these are impediments to experimentation and innovation, and reasons not to try to do things differently versus what you've done on premise. And so the challenge that I'm laying down, and that you'll see from Michael's presentation later, is that using the cloud in a different way, not just for storage, not just for processing, not just for delivery, but for a holistic change within your business, allows you to differentiate your company. It allows you to focus on your customers, what you're good at, which is generally making and distributing content, that user experience, the entertainment, the education. It lets you innovate quickly, and it reduces the risk of that innovation, meaning that you can try things quickly. And in the world that we live in, experimentation becomes really advantageous to what we do next in terms of new business and revenues. So how do we focus on this differentiation? So one of the things we look at is, and the cloud provides, is this fundamental tenet of getting rid of things that are time-consuming and costly. So one of them is around storage. So managing storage, operating storage, just for the sake of storing content as it goes from HD to 4K to 8K to augmented reality and different formats that you're going to have to distribute to. Managing storage is an overhead that you can get rid of, as is managing the compute required to create that content. So using compute as a utility, it was one of the fundamental premises of cloud, is still very relevant today as we look at transformation in the cloud. So compute as utility, paying for what you use, don't pay for what you don't use, match your CPU and GPU mix to the application and the workload or workflow that you're trying to drive. So if you build a very agile supply chain, whether you need a CPU at one point or a GPU at one point might be dependent on the file input or the file output. And the ability to swap quickly without that overhead of managing, installing, powering, running, looking at efficiencies of infrastructure becomes compelling. As does the ability to differentiate from a customer engagement perspective. So the ability to build new experiences, the ability to drive new revenue sources for your company becomes what agility and risk-taking is all about. And so the ability to fail quickly, to test more with less risk and less overhead, and driving that agility and innovation for what you deliver becomes a key component. And then finally, we all operate in a global marketplace. All of our end users are socially connected. What we're able to do in terms of driving and leveraging social media to deliver our content, new ways of engaging people, new ways of distributing, new ways of promoting content, means that you need to focus on that content creation and delivery rather than managing the infrastructure that underpins it. And so if we look at live news and live sports, we look at events, we look at global distribution, all of that requires infrastructure, and we hope that the cloud allows you to not worry about deploying and managing that infrastructure, but lets you focus on the actual workflows that you're building. So this focus on a core mission, so the premise being is that you can lower your time spent on infrastructure, concentrate on those new initiatives, and dedicate more resources to innovating around the content and the consumer experience. And so how do you innovate faster than ever before? So back to this slide, this agnostic supply chain, if we move it to the cloud, it gives you that flexibility and agility. It allows you to experiment. It allows you to try new things. It doesn't require you to have budget and CapEx and planning ahead of it. And that speed of execution, we believe, becomes very valuable. And we see as a big catalyst to many of our customers looking to transform many pieces of this workflow in the cloud, not just one or two of these items. So how do we do it? So from a platform perspective, there are many core components that we offer from the AWS perspective. If you're bringing in content to the platform, we have Amazon Direct Connect, that allows for a dedicated point-to-point connection, Amazon Snowball that lets you write content locally and ship that to AWS and have it written to your storage. We have many types of compute instances on the Amazon EC2 platform, from GPUs to CPUs to high memory to different processors, all that allows you for an agile workflow with respect to the content that you're processing. And when it comes to processing that video for delivery, we have two ways of doing it natively on the platform. We have AWS Elemental that is focused solely on video from a live and a file-based perspective. And if you read last night, we launched 5 new console services with AWS Elemental that really allow for that democratization of broadcast quality video, again, allowing for agility and experimentation. On the post-production side, we have ThinkBox software that allows for rendering and visual effects type of workflows. On the storage side, many different storage platforms to help you migrate your content. Object-based with Amazon S3, Glacier-based with lower cost objects, EFS and EBS from a block-based perspective, allowing you to match your application and I/O performance with the right storage. Amazon CloudFront for delivery. And then, interestingly, and I think a new way of us approaching the cloud is leveraging analytics and artificial intelligence and machine learning as a way of reinvigorating all of the workflows that are quite static and generally are ripe for transformation. Extracting that information becomes key. So these new advantages, these new computer models become key. So the ability to work on code rather than managing infrastructure, the ability to write code to respond to your workflows and your triggers and your inputs and outputs, and the ability to only pay for the code that runs rather than the infrastructure that's needed to potentially run that. And when we look at serverless, there are many technologies. AWS Lambda for running code at 5-minute intervals, Amazon S3 for notifications, DynamoDB for operating databases without the need for operating the database infrastructure, and many as we go on. And many of these are used to infuse into workflows in the cloud, allowing you to do things quickly and potentially very differently to how you've done them on premise. The ability to infuse AI and ML is another key advantage we see as people migrate. So if you haven't begun the cloud journey, this now allows you a refreshed view of what you might want to do in the cloud, or if you've begun your cloud journey, what it might do. See the ability to integrate Amazon Recognition for image analysis and extract metadata to derive new customer experiences from text to speech and speech to text. So all of that OTT downstream in your customer engagement becomes driven through AI ML from a recommendation engine perspective, from an interface perspective, from a usability perspective. And then we have a ton of ecosystem partners that help you integrate also. So in addition to our native services, we have many third parties that let you integrate from an ingest, a distribution, from a processing, from a broadcast playout, from an asset management perspective, from a DRM and encryption and distribution. So many third parties on the platform that help you leverage best practices and best breed solutions in the cloud just as you would on premise. And then the way this comes together, and as I wrap up, is sort of the general building blocks for supply chain or anything that you might do from a media perspective in the cloud. So storage becomes central. Building mechanisms to ingest into storage at scale, allowing for automation, allowing for triggers, allowing for metadata extraction as that content comes in becomes very compelling. As you ingest content, if you can extract and derive new metadata that you can use to power your asset management systems or your business processes, that potentially becomes very transformational. The ability to create and finish your content, the ability to process that content from a video perspective or from a post-production rendering VFX perspective, the ability to deliver, and then the ability to collect and analyze data across all of the entire workflow. And so this piece becomes very transformational. As Michael gets into his part of the presentation, you'll see how these building blocks allow for a very agile business process in terms of building supply chain from a delivery perspective. So my opening is really about how do we innovate faster than ever before. And next up will be Michael Cutter from Turner to talk about how they're innovating, but specifically the business drivers that they're using to drive that innovation, and then how the cloud is benefiting them from an agility and speed perspective. So I'm going to transition to this video. It should play. Thank you.
I thought the sexual tension was non-existent.
Dumbass!
You look super cute, but inside, you're garbage.
Wow. We live in this comic book world where either you're a villain or you're a superhero.
Titans, go!
This could actually be so useful right now.
Let me hear your battle cry!
It takes more than that to kill Rick and Morty, but this might do it. Run, Morty!
The entire Republic is hanging by a thread, and you're hosting this show.
You were moments away from utter annihilation. Don't touch me.
We had a good run, 10,000 years, wasn't bad, right guys?
Our country will get through this one awkward shoulder pat at a time.
Episode 1, I'm getting booed up in my own show!
You don't think it looks odd that the president is firing the guy who's leading the investigation?
He can do that.
He is the smartest man in the universe.
Feels like the end.
It is the end.
It's definitely the end! You sons of...
All right, yeah, cool. Hey, another reInvent. It's good to be here again. So yeah, I'm Michael Cutter, and I work at Turner. One of the cool things about Turner, as you could see from the video, is it's a business of scale. We've got genre-leading networks and a lot of different categories. I won't go through this whole slide, but you can see that there's a breadth of content. And what I think is exciting about this is it's everything from news to sports to scripted and kind of everything in between, cartoon. And so there's not that many opportunities out there to try to solve for this with a platform that can actually service all of those different types of content and types of businesses. So it's an exciting place to be. So if you think about like all of that content that's out there, you see here a little bit from the upcoming Snoop Dogg game show. That'll be kind of cool. You've got CNN, March Madness, all the way to NBA. And we've got work in progress, which is that kind of post-production stuff that's in edit. There's our incoming content, the raw camera masters, our raw feeds records, and the short form edits, and then the long form programming masters. And so I'm going to start by talking about some of these different categories, starting with the green stuff. And so just specifically around news, this is some stats from our internal app platform that supports CNN production. And so we've got right around 2,000 users internal to CNN that use this on a daily basis. About almost 74,000 incoming assets per month across all the different locations where these systems execute. We go almost 7,000 monthly edits, and that means that there's about 20,000 items that get archived really every month, which is kind of staggering. And the CNN library itself it's 30 years of news history. So it goes back to the days of tape all the way through standard definition, high definition. It's integrated with all our sites. And it's kind of priceless in a way. It's sort of a bit of a treasure. And one of the really great things about this is that there's awesome metadata for all the stuff in the library. And that's a lot of folks will come in and say, hey, do you want to do some image recognition or analysis? Well, we do. But the flip side of that is we have all the closed captions, the scripts, the logs, the time code, when it was recorded, who was in it. I mean, CNN has meticulously kept this stuff up for really their entire life. They've always had a great library team. So it's actually a very valuable resource. And this is a picture of the actual UI that the different staff around the company used to access the library. And you can see that there's Atlanta, DC, London, New York. Those are some of the production systems that are out there that all tie into Mira, which is the name of the library system. And when they are in here, they can browse keyframes. So there's a hover scrub on top of those images, as well as the ability to look at those keyframes. We took our 80% of our least used keyframes, took them off storage and put them in S3. And so now we have over 2.5 billion library keyframes sitting on an object store out there that we hydrate on demand for people that need to access some of that older content. Also, they've got the ability to do kind of instant, full or partial fulfill of these library assets to over 20 fulfillment locations, all in the right format for what they need in that location. And just to give a feel for what they're fulfilling, typically people are fulfilling content that is relatively recent. So the 1 to 5 years old, and then the greater than 20 years old. But a lot of the stuff is daily churn stuff that got archived 2 weeks ago, and they're pulling it back because the systems basically turn over about every week. They'll completely turn all their storage over as they record incoming material. And then you can see a little bit about the subject of those fulfillments. So obviously, like right now, national politics in 2017 is huge. And then flipping that back around, looking at ingest. And actually, I think that this bottom is a typo. It should say 200,000 ingest hours per year. So that just shows you from an hours perspective how many hours we're pounding into the library itself. So it grows at a pretty good clip year over year. And traditionally, we've had all these sites are integrated into the core common digital library, and then we've got Iron Mountain, right? So we create 2 LTOs, we spit one out, and it goes to Iron Mountain, and it gets put away in the salt mine, and if one of those tapes dies or gets corrupted, we pull it back, right? And then it's always that practice of loading it up and just hoping that data on that LTO that's been sitting in the salt mine is actually going to read correctly, right? And most of the time it does, sometimes it doesn't. And the other thing is those LTOs that are sitting in Iron Mountain, they're getting old. And so at some point, we're going to have to refresh all of those old salt mine tapes and do a data migration, which nobody's looking forward to, right? So it's kind of a problem. So we're like, how do we solve for this? And really what we want, this has always been our dream scenario, is a dual active, geographically redundant library system. So we've got library copy A and library copy B, and the two can operate completely independent of each other for that entire 30 years of news history that we were talking about before. And so we thought, well, how do we build it? If we're not going to use the salt mine, we got to build another library. How are we going to build another library? Well, should it be cloud and disk? So we could buy a big on-prem object store, right? And keep our current tape, put a little disk in there, see how that goes, and then migrate copy 2 to the cloud. We could do all disk, so we could build 2 giant redundant object stores. We could do all cloud. So maybe we could do East Coast and West Coast cloud. We could do cloud and tape, or tape only. And when we say tape only, what I mean is tape plus Iron Mountain. That's really what that scenario is. And so we looked at how much all these different scenarios cost. We looked at the equipment, the disk, the tape, robot, servers, whatever was involved. We looked at the data center, including the facility, all the supporting infrastructure, any operating expenses that were associated with any of these options, whether it was usage costs for AWS, whether it was support staff, maintenance contracts, power HVAC, and this is what we got. And so you can see the cumulative year-over-year spend. I actually took the numbers off of here because I didn't want anyone to have like some kind of weird heartburn over that. But you can kind of see relative to each other where these were. And this was a 2016 analysis that we did before we started the strategy. And yeah, sure, tape only with Iron Mountain was the cheapest, but it's also the least capable. It doesn't really offer us any kind of business continuity in the case that the main library went down. It would take months to rebuild the library and back it up. And you can see, actually, interestingly, all cloud, long term, was the next cheapest option. And that would be for 2 copies in the cloud, which was pretty excited. Where we ended up was that we are going to put 1 copy in the cloud, we're going to keep the other copy on-prem, and we're going to get rid of LTO and use an on-prem object store. So that's the kind of the 2-copy option that we ended up selecting. So I'm going to tell you a little bit about the cloud part of that strategy. So we've got our hierarchical storage management system that, whether it's tape or object store, will kind of tie that together. So, and we've got just over 17 petabytes of digital library assets, which is 2.5 million files. About 65% of that is the growing high-definition archive. And so we'll pull those files over to an intermediate cache where we upload it to Glacier. It goes into a Glacier vault. And then from that Glacier vault, we can pull it back to Amazon S3, where we can do any of our file chopping procedures if we want to chop a file for a partial fulfill. Keep in mind, most of this is variable bitrate material, so you can't just do simple byte offset to get a partial. You really have to have the frame accurate index of the file to find where the frame is that you want for the partial. So we'll do the frame accurate chopping up in S3 and then send it directly back to our fulfillment location. And you can see now there's 2 arrows. Any of those fulfillment locations will be able to fulfill direct from the cloud or from our storage. And coupled with this is currently 1 and soon to be 2 10 gig direct connects into the cloud, so that if we choose not to use public internet, we can have private bandwidth to make sure that works. And then the next step, the longer term step, is to be able to actually archive directly to the cloud and fulfill directly from the cloud. The reason this is important is if the stuff on the left-hand side of the screen goes down, like I told you before, these systems turn over about every week. They're gigantic TiVo systems that are recording hundreds of channels of satellite feeds, fiber feeds, news gathering feeds from trucks, everything we've got. And yeah, they're constantly reusing their storage. So if we can't archive from those systems, we're in deep trouble. So we have to have this dual archive capability. And then even longer term is when the current object store that we're buying is depreciated, we'll look and say if the cloud has been as good as we think it's going to be in terms of long-term archive and fulfillment performance, we probably will just cut over to 100% cloud with resiliency across multiple zones. And then from an architecture perspective, I had to provide some kind of eye chart with the Amazon logos on it. But you can just see here kind of basically the same type of data flow and the actual code elements, which are inside this Metro container that provide all the orchestration of moving stuff in and out of the cloud, which is kind of a key element. We have to be able to actually control that data movement and track the location of those files, whether they're on-prem, in the cloud, or both. So just to talk a little bit about some of the challenges in doing this, there are certain things about S3 and Glacier that are different, right? And I think that we're a little bit accustomed to working with hierarchical storage management systems that kind of have the intelligence in the system to decide where we want to put files, and the lifecycle management on S3 is not quite the same. So, and I'll just point out here, you've got your S3 containers are buckets, buckets contain objects, objects contain metadata. When you flip over to Glacier, you go from vaults to archives to date and description, right? So you actually have to do some data management as you're moving back and forth between these two storage domains. Something we didn't quite expect, and I think it's sort of an opportunity. But that said, even just in the last couple of weeks, this has improved a little bit. So we do think Amazon is listening to this, and we're seeing some results. So I'm going to transition from that to talk a little bit about the long-form library. So the long-form library is all of our completed programming masters for all the networks at Turner, TNT, TBS, CNN, what have you. And it's not nearly as big as the CNN library, because that thing's been piling up for 30 years, but it's really, really complex. And I do want to thank Steve Fish, who's lead of Turner's International Tech Strategy, for helping me with some of the slides that you're about to see. So the really complicated part of this story is just how many derivatives get created from a single input. And probably you guys have seen something like this before. Let me get back. We get one input asset, but as you go across all of the different platforms, all of the different partners, like EST and SVOD partners, and all of the different regions, which have their own EST and SVOD partners in every region, you get really a ridiculous number of versions that are being created from a single input asset. And these are not just like encoding versions. These are fundamentally different audio, different video, different graphics, different cuts for standards and practices, different runtimes. I mean, there's a lot of variation across this, and then you add the encoding deltas across that, and it's even greater. So there's, and the problem really, not only the complexity of creating these, but now we've just, in this model, we've done processing and stored all of these along with a whole bunch of intermediary files that are required to generate each one. So it's an incredibly inefficient model, and I will just say, this is kind of how the media business works. I don't think that this is unique to Turner. This is how a lot of companies have created a global content exploitation strategy. And I'll just point out one more thing. If you're a Netflix or Amazon Video or Hulu, you kind of have one product, right? That all your content is going into. And I think one of the big challenges here is we have so many networks, so many platforms, so many products, and we have to be able to service all of them, equally. So that's another challenge. And this is what happens, right? So when we first get an asset in the door, we know a lot about it, right? The knowledge level, the metadata for that is at a maximum. But frankly, over time, I would call this sort of bit rot. You lose a lot of that information about that asset. And that typically is not because we lost the metadata, but it's the file's been transcoded, it's been sent to another part of the business. Now they're doing some transformations on it. They might be adding localization to it. And slowly, that metadata starts getting stripped away from it as it moves through this big process. And so if you think about it, that over time, that lost knowledge results in really a reduced speed of exploitation. Right? So now we're way down the line. We're operating in this sort of orange zone up here. We know less than we ever knew about this asset, but we're looking for exploitation speed. So what's causing that? I think one of the problems we have is quality. And so if you're familiar with video frame rates, you can see we go from 24 frames a second, which is typically a program master, all the way up through 25 frames a second, PAL, 30 frames a second, NTSC, 50 and 60 for the high frame rate. And we're as we go from S&P to dialogue and sound to a transmission master, we're jumping frame rates all over the place. And this is a huge problem because if you guys are familiar with the way that frame rate conversions happen, it's not just adding or removing frames or speeding things up and slowing things down. There's frame blending. There's destructive actions that are occurring with these transformations, and it causes video quality problems. And that's why, in a lot of cases, I've seen, at least for us in the early days of SVOD, we had a lot of files getting kicked back. And when we really looked at it, it's because there were a lot of these upstream quality issues with specific to frame rates that were happening. And that wasn't good. That cost us real money. And then don't forget, frame rate is only one dimension of this. With a lot of these conversions also come transcodes, different bit rates. We're looking at standard definition and high definition and color space. And oh my God, HDR makes my head want to explode when we start talking about high dynamic range and what it means for these workflows, because it adds a whole nother axis of complexity onto the whole thing. So, and this is Steve Fish's teddy bear, I thought it was appropriate. We're looking for something that could eliminate or at least substantially reduce duplication, preserve asset knowledge, and preserve quality. How can we go about doing that? And I thought that this was very lean, so if you know Shigeo Shingo, he's the Toyota father of total quality management and the kind of the person that originated a lot of the concepts around lean and elimination of waste. So these are the dimensions: easier, better, cheaper, faster. That's really what we want. So here's this massive duplication, and you can see for that one video and all those audios, it really does get a little bit crazy. So we want no duplication. So how can we do that? Well, if we take our library master and we take this little insert, great, there's no duplication. But here's the problem. Where do we put that little insert? How do we keep track that that insert was the right insert that goes with that particular version? And how do we make sure that it can be inserted consistently every single time? And now we've got region 2. Well, that's easy. We took the region 1 version and we added a couple more inserts. That could be everything from maybe localized graphics to maybe it's actually an edit where we're chopping a scene out. Some of those inserts could be removals. And so new content, where to put it. So we've got this idea of a component-based asset. So we've got the library master, we've got all our inserts, and we've got all of the tracks that we added over time. And we create what is really an additive process as we go through here and create this idea of a component-based asset. And this has been tried multiple times before, but I think that we're finding as we're moving into the cloud that this is actually an interesting challenge, because it's not something that appears to have been done before easily in the cloud that we can just pick up and use somebody else's model. So as we go for this idea of rapid monetization, now we get our exploitation speed up, because if you look back to that component-based asset, we haven't lost any of that knowledge. We're operating off of the original master the whole time. There's no transformations that are stripping away knowledge as it moves down the workflow. And then if you look at the quality, it's actually pretty cool because we're operating at that master frame rate all the way up until the point where we create our final transmission or video on demand distribution assets. So that's a huge plus on the quality side. And then if you add in all the complexity around codec, bitrate, definition, color space, there's a lot fewer transformations, and all the transformations do happen at the very end of the workflow, not all throughout. So this is really a solved problem in a lot of ways. If you guys are familiar with IMF, it's the interoperable master format. It was defined through SMPTE with Hollywood really driving the need. And Hollywood has a very specific set of use cases that they need to solve for as they distribute to all of their different markets. It's a little bit different when you come to somebody that's sitting at a different place in the supply chain, which is where Turner sits. And so we're working to essentially adjust the application profiles for IMF so that they're suitable for companies like Turner. So we store everything once at the highest quality. We have lightweight XML compositions that define each of those individual versions. And then basically just take those recipes for each version that point to the ingredients, which are all the components, and say, hey, create it just in time, right? And we're trying to create that kind of pull-based model. Don't process media that doesn't need to be processed. Only transcode the stuff that's actually needed. And it happens to be really cloud friendly, because if you look at that model of all of those individual components that I talked about, they're objects, right? So to be able to put them in an object store is really a very straightforward thing to do. And now we've got the individual XML artifacts that are part of IMF that help us define the way that those objects link together. So that worked pretty good. So this is the data flow. So we take a distribution master, and we go through the fission process where we basically transcode that, atomize it, and run it through an auto QC process. So now it's been that self-contained media file that came in the front door has been broken apart into its components and QC'd. It's also been normalized into a library standard codec so that we don't have lots of variability in there. Because again, if you think about lean and eliminating waste, anytime we see defects occurring in that final output processing, that's waste, right? So if we can deal with that up front and get pristine, canonical library masters, we want to be able to count on just-in-time delivery of those very consistently. So that transcoding into a standard format is a really important part of that. That goes in the IMF library master, and that's really where we're talking about scaled storage, right? We need the ability to grow out that library without a lot of constraints, and that's where we're leveraging S3 and Glacier. And so then the other side is defining the recipes. And so we're working with company SDVI to build the cloud recipe generation capability. So that'll be basically Adobe Premiere, going into an edit session, defining those recipes, and then saving those recipes in a database so that we can call them on demand to be baked off into those final distributables. And so that's where we need to scale our compute, because we're not just baking down that MES file, but we're actually creating those final distribution copies that'll go to everything from air to electronic sell-through. And we're working with NABA, which is the North American Broadcast Association, and the Digital Production Partnership to take IMF and really adopt it to the needs of this particular supply chain that I'm talking about right now. And some very specific things that are coming out of that include ProRes mapping. So instead of JPEG 2000, which is a very kind of awesome from a quality perspective, but a very heavy processor-intensive codec, we'll be looking at ProRes is a more kind of broadcaster-friendly format to store those masters in. And also really trying to get all of the track labeling and all that kind of stuff sorted out so that we've got a broadcast-friendly IMF model to work with. And so, I talked about the raw camera masters, all of this kind of CNN library type stuff in the green, how we're putting that in the cloud. Our long-form programming masters, how we're putting that in the cloud. And it's all been an interesting journey, but we're pretty excited, and it's actually working out really well so far. So that's it. I think we have some time for questions. Yeah, thanks.